Hey guys, Mr. Gron here with a quick challenge video. Something that you would be expected to be able to do in a class like pre-calculus is solve exponential equations exactly using logarithms. So here's how that would look. We looked at some problems like this in class last week. Miss Amundsen has $100 in her savings account. It earns 3% annual interest, and we want to know how many years will it take to double in value. What we did in class was we made an exponential equation, and then we used the graphing calculator and the table function on the graphing table to just like scan through and figure out what year, about how many years, how many full years. But what if we wanted to find it exactly, or in this case to the nearest hundredth? You would use something called a logarithm. So the way we would start this is we would set it up just like a normal equation. So we've got 100 for our initial value, so 100. We're earning 3% interest, so that is going to be 1 plus 0.03. And that is to some exponent we're not sure of yet. That's how many years it's going to take. And we want to know when it doubles in value. So we want to know when it's going to be equal to 200. All right, so now when we're solving for x, we're going to start this out with the outermost layer first. Our outermost layer is this 100, right? We're trying to get rid of that so we can get to the x. We're getting rid of that first. So I'm going to divide both sides by 100. And I will get that 1.03 to the x power is equal to 2. So what I really want to know is what power do I need to raise this number 1.03 by to make it equal to 2. And I do that using a logarithm. So if you look on your graphing calculator, right next to the 7 it says log. That's what we're going to use. Now we're going to use it in our work first, and we'll save it for the calculator in just a second. So what I'm going to do is take the log of both sides. So that log should go in front of the 2 is how that should look. All right, so now when I rewrite this, the special magical thing about a logarithm is it allows us to solve for this exponent. It makes that exponent no longer the exponent. So what we do is we take whatever that exponent is, in this case x, and we can move it in front, and log of 1.03 to the x is the same as x times log of 1.03. That's the special trick here, the little magic thing with logarithms. It's not really magic, but it's too complicated for this one video. All right, so now that we have this, these two things, this log 1.03 and log 2, they're just special ways to write weird numbers, just like sine of 60. You plug that into your calculator and it's some weird number. Same thing with like the square root of 5, right? We can write it as the square root of 5 instead of having to estimate a really weird decimal number. Same idea here. Well, I can take that log of 1.03 now, and I can divide both sides by log of 1.03 to isolate our variable x. So that'll cancel out the log of 1.03, and what I'll be left with is x equals, and this is what I would plug into my calculator over here, this log 2 divided by log of 1.03. Plug that in, pretty much how it looks. And if you do that, you should get 23 about 45, so about 23.45 years to the nearest hundredth. All right, so there's two examples for you guys to try if you choose. I'm going to move to the next slide, pause it, try it out, and then the slide after that, the next 10 seconds of the video, will be the key for it. All right, either pause and unpause when you are ready. Here is the key. So pause and take some time to look at what you did, if you came up with the same thing. And pause and try this one. Notice this depreciates, so it's instead of 1 plus 0.12, it's 1 minus 0.12. And unpause if you are ready to check the key. And there is the